Happy Friday, everybody. I'm off at senior retreat right now, retreating while you're here in class. I do apologize about that. So let's move through these as fast as possible. Hi, everybody. I love you. Free response number 4, practice part 2. We're going to go through it just like we did last time. Again, I'm going to go through the example just to reinforce it. They say a strip of magnesium is added to a solution of silver 1 nitrate. When they see the word solution, you're going to see the ions. Magnesium is going to go up in charge to 2 plus to react with NO3 minus. Ag's got to go down in charge. Mg's going up, Ag's going down. Connect and cancel. Balance charge. And the substance who's being oxidized is the one who goes up in charge. And that, in this case, is magnesium. It goes from Mg0 to Mg2 plus. It's oxidized. It's also the reducing agent. This will always be the example for this section. Okay, here we go. Balance this reaction. Zinc metal reacts with dilute hydrochloric acid. Zinc metal, Zn0. It's going to be a solid. It's going to come into play later when we talk about equilibrium. Reacts with dilute hydrochloric acid. Okay, we got to remember something here. Dilute does mean it's in water, but this is an acid, and it's a strong acid. Strong acids always break up into their ions. And if they're broken up into their ions, they are aqueous. Similar to the above reaction, zinc's going to go up, and I didn't mention, but zinc usually goes up to 2 plus. Take it to 2 plus every time. Cl is going to be minus. They're broken up, so that's going to be aqueous. And hydrogen's going to get kicked out. Remember, hydrogen is a Twinkie. And it's a gas. Going to balance this reaction, put 2 H's there. Cancel the spectators, and we have our balanced reaction. How would increasing the concentration of hydrochloric acid affect the equilibrium of this reaction? Okay, equilibrium, first off, this counts, this counts, this counts, this does not count because it's a solid. Increasing the concentration of hydrochloric acid. If you increase hydrochloric acid, everything's going to want to shift away from it. So it's going to shift this reaction to the right. Okay. Add too much hydrochloric acid, it's got to get rid of it to get back to equilibrium. Now, one way to think about it is this whole thing's on a teeter-tot. If you increase hydrochloric acid, the whole thing is going to shift down here to the left. So the only way to equal that out would be to shift it back over to the right. I don't know if that made sense to you. B. Liquid ethanol is burned in air. Ethanol is C2H6O. It's liquid. It's made out of carbons, hydrogens, and oxygens. So burning means plus O2, arrow CO2. So gases plus H2O. Gas. Going to put a 2 here. Going to put a 3 here. Going to put a 3 here to balance it. How would using a fire extinguisher, which is made out of carbon dioxide gas, influence the equilibrium of the reaction above? Okay, so gas counts, gas counts, gas counts, liquid doesn't count. Adding carbon dioxide, okay? Adding carbon dioxide would be equivalent to increasing CO2. Increasing CO2, you shift away. In this case, shifting away is to the left. So answer, shift left. Using our teeter-totter model, increasing CO2, make this side heavier. It's got to go back to the left to get back to the balanced position. Basically, you're convincing the fire into thinking that it produced all this CO2 on its own. So it stops producing CO2 and shifts back to reactants. C. Calcium metal is burned in the presence of nitrogen gas. Calcium metal, Ca0, it's going to be a solid. Now don't automatically put O2 just because you said burned. If it doesn't say burned, we'll be using O2. But in this case, it does say nitrogen gas. So nitrogen gas, this is also 0. It's a gas. Yeah. Well, if you have two things that are both 0, one's going to have to go up in charge and the other's going to have to go down in charge. In this case, calcium is going to go up to 2 plus, and nitrogen is going to go down to 3 minus, and it makes Ca3N2. Now, notice here that there is no sign of water anywhere. No water anywhere, so we could not have a liquid. We could not have anything that's aqueous. We need water for that. So the only other choice is gas and solid, and this is an ionic compound here because it has a metal. And ionic compounds are never gases. We'll go over that later. So you have a solid, that's not going to count for equilibrium. You have a gas, that's going to count for equilibrium. And you have a solid, it's not going to count for equilibrium. Let's balance this reaction, though, by putting a 3 there, and it should be balanced. So let's see what they're asking. How would injecting more nitrogen gas into the reaction chamber influence the amount of products? Okay. These are products. Does nitrogen count? Yes, it does count because it's a gas. Injecting more nitrogen in would increase the amount of nitrogen. It's going to have to shift away from nitrogen to the right. So this reaction would shift to the right. Have a great weekend, everybody.